Hi, good morning, and welcome to the fifth Quantum Computing Weekly Recap. This week we have some very interesting news tying crypto, AI, and quantum together. We're going to talk about Bitcoin, we're going to talk about some new funding to increase enterprise applications, funding for better AI. We also have some awards, and let's get right into it. For the first article of this week, we actually have interesting research coming out of the University of Kent, which discusses what it would take to make Bitcoin quantum safe. And since Shor's algorithm in the early 2000s, we've known that quantum computers are able to attack certain encryption schemes. In Shor's case, it is the RSA scheme. So what it would take is, in classical computing, we call it a trapdoor function, where it's very easy to move in one direction and extremely difficult to move in the other direction. So for RSA's case, that means taking two very big prime numbers, multiplying them together to create an even bigger coprime number. The difficulty is it's easy to multiply two numbers, but it's very hard to figure out what numbers multiplied to create that number. With Shor's algorithm, it can actually find the period of the wave of that extremely big coprime number, and that period can help you determine both of the numbers that were used to multiply, effectively breaking the encryption. And what this research says is that it would take over 300 days of downtime for the Bitcoin network. This is a little bit exaggerated. Really, what it means is you would have to spend 25% of the network 4 different times slowing down rates, by 25%, slowing down transactions, slowing down purchases, everything, maybe increasing gas fees, all of that for 305 days. But if you wanted to take the network completely offline, you could do it in 76 days. And technically, it is possible to fix Bitcoin's encryption by doing this. The issue is everybody bought Bitcoin because it's decentralized. So if it's decentralized, how do you get all 2 million people who buy Bitcoin? Yeah, 275 million people to all agree, hey, let's stop doing transactions and let's upgrade to this new encryption scheme. And what that would also take is re-encrypting all of the transactions that have ever happened on the blockchain. So this is a kind of a difficult situation that Bitcoin finds itself in. As we saw last week, companies are making huge strides with error correcting qubits, scaling up qubits, new qubit technologies. If you want to watch that video, check it out, because a lot happened last week and it's got people thinking, well, what is the biggest thing that's currently at threat right now? And that would be Bitcoin with its all-time high of $106,000 a Bitcoin. So very important research coming out. It's kind of a wake-up call for everybody who's invested in Bitcoin. That's like, yeah, we bought something decentralized. Now, how can we bring people together to make it quantum safe? We'll see if that ever actually happens. Maybe it'll happen when quantum computers get closer and closer to breaking Bitcoin. People will realize, hey, I'll lose all my money. Or they'll transfer to a new cryptocurrency so they don't have to do that. We'll see. For the next story, BlueQubit, a very cool quantum SaaS company, has raised $10 million to start researching enterprise solutions for finance, medical, etc. So what they're doing is they actually have a fleet of GPUs, and they're able to kind of test out different potential solutions on their GPUs. And when they find out that, hey, this algorithm works well, then they deploy to quantum processors, QPUs. And this is saving people a bunch of money to develop this way, because running something on a quantum computer is very expensive, but if you run it on a GPU, it's still quite expensive, but it's nothing compared to the cost of a QPU. So congratulations to BlueQubit. That's an amazing fundraising round, and they are going to be able to really help a lot of different industries that need to start developing algorithms. And that's the other thing. There aren't enough great quantum algorithms out there that things like fleets of GPUs to effectively simulate enough qubits that can actually show you real quantum results, like real quantum algorithm results. That's getting more and more necessary as we're approaching the time when quantum computers will be useful. And then once they're useful, the question is, well, how can my company use that? BlueQubit's positioning itself as a player for that next stage, where quantum computers are useful, now companies want to use them, and BlueQubit is right there, ready to integrate their algorithms. So big congrats on their 10 million. That is fantastic and well deserved. Now, multiverse computing is coming at the new angle of AI and quantum computing, and what they're actually doing is they're trying to tackle the problem of energy efficiency. And this is a huge issue that we've seen. You know, Microsoft is acquiring nuclear power plants. Everybody is trying to figure out, like, how do we make the next big model? Because ChatGPT and the latest O3 model are just power hungry things. Training it takes millions of dollars, and then running it takes, less than that, but still millions of dollars. So it's absorbing a ton of energy, and we need to figure out more efficient ways to do this. And what multiverse computing is doing is they're using their quantum-inspired tensor networks. So I guess they took inspiration from how quantum computers learn, or how the quantum state evolves within a quantum computer, and there are efficiencies in quantum through entanglement. They might be leveraging some of this design in their classical AI accelerators. So what they got was basically funding that's in Italy, and they're building out an office in Milan, and they're going to try to figure out who they can work with in Italy to actually bring their quantum-inspired tensor networks to fruition. This is a fantastic Series A round, and it's a area of research and enterprise that we need to be tackling. I think that's why they got so much funding to enter the Italian market. They got 25 million euros, so they got a lot of money to start building up this technology and to integrate it with Italian companies. So congratulations to multiverse computing. Decreasing the energy requirements on AI is probably the next big challenge for AI. Finding better data and decreasing energy requirements. Those two big things, I mean, they're tackling one half of the puzzle. So good job to multiverse. And as we touched on last week, we had incredible advances in quantum error correction, both from Quera and from Google. So this year's 2024 Breakthrough of the Year prize by Physics World was awarded to Mikhail Lukin, Dolev Blufstein, and the colleagues at Harvard and MIT with Quera. And then separately, part of Google AI is Hartmut Nevin and others who helped bring quantum error correction to both of these different groups. Massive congratulations. That last week was an incredible milestone for quantum, and Physics World definitely felt that. And I think the whole world did when we are now seeing the transition from really bad quantum computers to actually useful ones. And these people just kind of helped bring that entire process forward significantly. This is a formidable task. So it is one of the, I guess I've heard the term people say in the quantum field is, how many miracles do you need to make your quantum computer useful? And quantum error correction was one of those universally accepted miracles that needed to happen. And here we are. We have the case where we have error-corrected qubits that use a bunch of physical qubits to correct one big qubit, and that qubit can hopefully keep its state, which is very fragile, for a long enough time to perform useful algorithms. So you're kind of seeing across these stories so far that everybody is either working on algorithms or making the qubits better, and we are very slowly bringing this field to the point where we can actually use it in enterprise. Switching gears a bit, a team from Northwestern University was actually able to use existing fiber optic cable, public fiber optic cable, to transport quantum information. And this is very exciting because universities like University of Maryland and others are laying down quantum fiber optic cable, and it's costing a lot of money and a lot of time. But what actually could be possible from this research is we don't even need to lay new lines. We have fiber optic cable stretching, millions of miles around the world. So they're able to actually use that. And it wasn't as simple as just throwing entangled photons or photons with quantum properties into the cable. What they had to do was devise a specific wavelength and frequency of that photon such that it didn't interfere with the other photons. And what I mean is a quantum state is very fragile because anything that resonates with it can become entangled. That entangled thing can bounce off walls, blah, blah, blah. Soon, any of your little photons becomes entangled with the whole world, which effectively makes it destroy its quantum state. What they were able to do was design a very specific frequency that could actually not have any interference from classical channels. And what that was done is they looked at a bunch of different photons in the public internet going through fiber, and they figured out what specific frequency could not resonate with those. It's very exciting. I'm looking forward to seeing when we can just start having quantum internet where our encryption is provably safe, and our information is probably transmitted more quickly. It'll be a very exciting time when we can actually use our public infrastructure that's already laid down with fiber and use that to perform quantum communication. So massive congratulations to Northwestern University, and I'm looking forward to seeing later research from them. They want to extend the lines. They want to maybe even use cable that's being used by the public actively. So we're going to see what happens. I'm sure a lot of great research is going to come out of this team. And our last story also relates to fiber optic cables. Eurofiber, who has a bunch of fiber in Europe, they're working with Juniper Networks and Quantum Bridge to actually create quantum safe cryptography. We have a little AI generated picture here, but there are these approaches for quantum, and one of the most popular is quantum key distribution, which is a provably safe quantum encryption technique where you can guarantee that when you do your key exchange with somebody, that key is completely yours. No one else has tampered, no one else has spied on that key during the exchange. And key distribution is one of the foundational encryption requirements on the internet. When you go to any website and it has the little lockbox at the top showing that it's HTTPS, there was a key exchange, and that certificate was proven through that key, that public key that they actually gave us. But if somebody could intercept that traffic and give me their own key, they could make this website do whatever they want, and my computer would think, oh, hey, it's fine, it's proved to be safe. But that's because the key was tampered with. Quantum key distribution protects that entire area. So we both need to have quantum information traveling over the internet, but I think maybe the first step is let's make sure everybody's internet traffic is safe, and then let's go quantum. Thank you so much for listening to the latest Quantum Weekly recap. I hope you enjoyed it. We have a lot of exciting news, especially after last week's. We're feeling the quantum effect around the whole world at this point. Different industries are really taking notice, especially financial and health industries. So looking forward to next week. Let me know if you liked the video. Hit like, hit subscribe if you want to see next week's video. If you didn't like the video, please let me know why. You could dislike it and I'll try to improve for next week. Thanks, you guys. See ya.